Hi, my name is Lucinda Welch, and thank you for coming to my presentation on primary production in the near polar zones. Primary production is a process that's vital to life on Earth. Photosynthesis by ocean phytoplankton accounts for more than half of the world's oxygen production. Data is collected from multiple ocean arrays located in strategic oceanographic areas from around the globe. And some of the data collected tracks chlorophyll A concentration, which is a key indicator of primary production. For this study, chlorophyll A concentration data was collected at 3 near-polar locations: the Erminger Sea Array in the North Atlantic, the Station Papa Array in the North Pacific, and in the South Pacific, the Southern Ocean Array. It was found in all 3 of these locations that primary production increased between the spring and the summer months, and this is most likely due to an increase in sunlight, warmer surface water temperatures, increased precipitation causing runoff, and or ice melt depending on the location. The Erminger Sea Array, had the most significant spike in chlorophyll A concentration, and that happened between May and June. This increase might be influenced by geographic location, as that array is located close to the coast of Greenland. And while that's not really a heavily populated area, the summer ice melt could be a contributing factor. As the glaciers melt, nutrients are released into the sea, and that area is also known location of frequent upwelling. So those nutrients in the deep water are brought to the surface, and the nutrients combined with the extended exposure to sunlight during the summer months is the perfect recipe for primary production. Primary production is actually the creation of new organic matter from inorganic substrates. This organic matter that they create, that the phytoplankton creates, serves as a food base for most marine consumers. When we talk about primary production, we're generally referring to photosynthesis, but primary production can also be carried out by bacteria without sunlight, and that's called chemosynthesis. But for this study, we're going to concentrate on photosynthesis, specifically photosynthesis by microscopic algae called phytoplankton. Phytoplankton are responsible for most of the photosynthesis in the ocean. Actually, over 90% is carried out by phytoplankton. And they supply the Earth with more than 50% of its oxygen. Oxygen is obviously vital to life and a good thing, but however, an overabundance of phytoplankton can actually cause harmful algal blooms, also known as HABs, and they can have a negative impact on marine life and dissolved oxygen levels. Primary production is commonly measured by the concentration of chlorophyll A. You'll hear me say that a lot. Chlorophyll A is a main pigment that is found in primary producers. So they look for that chlorophyll A, and then when they see spikes or high levels of it, they know that primary production is in fact occurring. Primary production is influenced by the ocean's physical and biological processes, such as upwelling, circulation, surface temperature, stratification of the water column, and absorption of that good old solar radiation. So in this project, the chlorophyll A concentration data was collected from 3 separate arrays in the near polar zones. And when I say near polar, that means near either the southern pole or the North Pole. So 2 of the arrays were in the northern hemisphere and 1 in the southern. The data was collected over the course of a year, and each array consists of 3 data housings, and they are set out in a triangular set of moorings. Each side of the triangle roughly covers 10 times whatever the water depth is. And then they use a fluorometer at 2 or 3 wavelengths to measure chlorophyll concentration. The Irminger Sea Array is the one in the North Atlantic, right off the coast of Greenland, and it's at a 2,800 meter depth. The Station Papa Array is in the Gulf of Alaska, and that sits at about 4,200 meters. And the Southern Ocean Array is down in the South Pacific, and that one sits at about 4,800 meters. So during the scientific data collection, they noticed that concentrations varied over time. And in the North Atlantic location, the highest levels of chlorophyll A were seen between April and July. And in the North Pacific location, which is the Irminger Sea Array, it was seen between February and May. And in the South Pacific, they saw consistently low chlorophyll A concentrations between February and November. And actually, the rest of the year, none were seen at all in the South Pacific. So December and January, there were no chlorophyll A data retrieved at all. These increases in primary production were only seen during early spring through the summer, which indicates that in the near polar zones, sunlight is a really important factor for primary production. The Irminger Sea Array in the North Atlantic saw the greatest amount of primary production between May and June, and that's most likely due to, again, an increase in sun exposure, but that area is also known for thermohaline circulation, and it's pretty common there. So that could be another factor. Another consideration for that spike at the Irminger Sea Array might be the geographical location. As I mentioned earlier, it is right off the coast of Greenland. And there's a definite relationship between primary productivity and location on the globe. Chlorophyll A concentrations are higher in the coastal areas where nutrient-rich runoff enters the ocean. Like I said, the Irminger Sea Array off the coast of Greenland, Greenland is not really a heavily populated area along the coastline there, but it does have glaciers, and during the summer months, they melt and dump nutrients into the ocean. So it may not happen from agricultural runoff, but it does happen from the ice melt. Also, shallow, warmer waters on the continental shelf, along with the increased sunlight for the season, they also encourage primary production. Primary production varies geographically and seasonally. Phytoplankton production decreases as we move away from the coastal areas. And two reasons that occurs are actually explained in our textbook. First, runoff from the land contains a high abundance of nutrients, and they get deposited into the coastal waters and stimulate production. Second, the shallow bottom, like I mentioned earlier, along the continental shelf can trap nutrients and prevent them from sinking. Heavily populated coastal cities can impact primary production in a few ways. Agricultural runoff, as I mentioned, construction, which causes erosion, pollutants, even aquacultural facilities can affect primary production. These effects are noticeable in data retrieved in areas near coastal development. We know the implications of runoff from agrochemicals, but how do we control these pollutants and maintain balance in coastal areas? Another question I would be how does climate change affect these near polar regions, and how will ice melt influence future data? And lastly, what effects do severe storms play on data results? So thank you for coming to my presentation, and you all have a great day.